Hello everyone, Mr. Wickens here, or Lil Wickens as I'm also known by. And I think today was pretty fun telling you all about my YouTube channel. I think you're all pretty excited about it, and I think I'm going to try and keep making more videos because that sounds like what you want from me, so I can keep doing that. Thank you, Finn, for the suggestion about the lighting. I think that's made it a little bit better. And I'm going to see if I can make the audio a little bit better, get maybe an editor actually, and play around with the clips. But there's some good things in the works, so you got more videos coming your way. So, let's jump into what we were looking at today and what we'll look at tomorrow, which will be triangular prisms. So, finding the surface area of those objects. How are we going to do that? Well, let's draw a triangular prism. So, I'll start with the first one we're doing as a isosceles triangular prism, meaning this front triangle here is going to be an isosceles. So I'll draw that there, finish that up this way, and over that way. So we have this triangular prism, and because it's isosceles, then these two side lengths will be the same, and let's give them a length of 13. So 13 there and 13 here, and this base here will be 10. We'll give this a side length of 10, and this side one will give, let's say 25. I don't know. I pulled that number from my head. We'll see if it's a good number or not. So what we have to do for the surface area here, and Mr. McGuire keeps reminding me I need to put some units on there, so I'll put some on right there, and we'll calculate this with the units on there. So what we have to do for surface area is we have to find the area of each of the faces. So we have, because it's an isosceles triangle, let's look at the triangle first. We're also given, let's say that we're given the height here, which is 12 centimeters. So this height right here on the triangle is 12 centimeters. So if I look at the triangle on the front, we'll have a height of 12, side length of 13, that doesn't matter right now, and a base of 10. Now, I didn't draw this very well, but this will be cutting it. Oh, it doesn't matter. Because this base is 10 centimeters here, we have that the area is 1/2 base times height, which is going to be 1/2 times 10 times the height, which is 12. So I see that that's going to be 1/2 multiplied by 10 will be 5, and then 5 times 12 will be 60. So the area of the front piece will be 60. Now, the area of the back piece will also be 60 because they're both the same triangle. So if I start making a running total, why don't I use green? My blue marker is running out. So surface area, we'll put those two on there and we'll have 60 plus 60. So we have that so far. Now, what other shapes do we have on here? We have these, the front side here, the back side, and the one underneath. Now, if we think about the sides coming off of this one and the side coming off here, the dimensions are going to be the same because this side length here, and this side length here are the same as this side length here and this side length over here on the back side. So this back piece and this front piece are going to be the same area, are going to have the same area. So I'll draw those right here. Why don't I make some space here, and I will get rid of this one. So we found the area of the front and the back triangle. Now let's find the area of these two side rectangles. So we have a rectangle with a side length of 25 here, and then a height of 13. And again, that's the same one as this back one that has 13 here, and a length of 25. So we have 13 centimeters and 25 centimeters. So when I find the area, that's going to be 13 centimeters multiplied by 25 centimeters. And I'll put the units on that one in a second here. So when I multiply those together, I actually need a calculator, because when I made up that number, it did not give me a nice one to multiply with. So 13 times 25 is going to be 325. So this is 325. And the units are centimeters squared. I have squared units because the area is a squared space. So we have 325 for this part and 325 for the back part. So I'm going to put, now this was supposed to be 60 centimeters squared plus 60 centimeters squared. And I'm going to put two more of these on. So I'm going to put plus 325 centimeters squared plus 325. And again, you could have gone 2 times 60 plus 2 times 325. So the last one we need to do is going to be this bottom piece, and that's going to have, I erased it, but this was 10 here. So this distance here was 10. So the bottom piece, if I use this drawing that I already have, is going to be 10 by 25. So instead of having 13 here, I'll have 10 centimeters, and this is just going to be 10 multiplied by 25. 10 centimeters multiplied by 25 centimeters, and that's going to be 250 centimeters squared. So I'll put only one of those on there. 250 centimeters squared. And when I add all that up, can I make a guess? This is going to be 120. So I'll have 120 centimeters squared plus 650, I see, 650 centimeters squared plus 250. So that's going to be 800 plus 50 and 50 is going to be 900. So 120 plus 900, that's going to be 1,020 centimeters squared. So that would be the answer for that one. So that would be how to find the surface area for a triangular prism. Now, if I were to think about the net of that object, that would look something like, I could start with the front triangle, and I could think about all the, I'll redraw that a little bit. I'll redraw the rectangles coming off of it. So off of this side, right here, we have this rectangle, and off of this side we have that rectangle coming off. So here we'll have a rectangle coming off. Here we'll have the same rectangle coming off, because this side length is 25, and this side length here is 25, and these are 13, 13 and 13. And on the bottom one I have this last rectangle coming off of it, and that's going to be one that looks like this, which is, again, a 25 length, but it's only 10 on the bottom. So this is going to be 10 centimeters. And I'm forgetting that last triangle, and I can attach that last triangle to any one of these back pieces, but I'll put it right here and have that triangle there. So you could be given this on a test as well, with all the areas on each of these pieces, or you could calculate them. And the areas of these are 325, 325, this one was 250, and these were 60 each. So you might have to look at all those and add them up to get the surface area as well of the net. So I could go over another one really quickly. Why don't I think about one that is a scalene triangle? That means where all the triangles have a different side length. All the side lengths of the triangle are different. So we could have something like this, and this might look a little familiar to something from the booklet. So here we have a right angle right there. And let's say in this one we are given 8, 15, maybe 8 millimeters 15 millimeters, and this one can be 20 millimeters. So this length here is 20. I can already calculate some of the faces, the area of the faces. I could calculate the triangle. So if I go through this one quickly, I have 1/2, the area of this triangle is going to be 1/2 times height times the base, which is going to be 1/2 of 8 is 4, multiplied by 15, that's going to be 60, and it's millimeters squared. So I have two triangles there. I'll say 2 times 60 millimeters squared. So I have that one. I have, what else can I do? I have the very back piece, the back rectangle, which is 8 by 20. So the area of that is going to be 8 times 20. I think that's 160 millimeters squared. So I have that back. Now, because all of these rectangles are unique, I can only add them once. So I have plus 160 millimeters. On the bottom, I have 20, but then I have this side length of 15. So this one should be 15. 20 times 15, I think that's going to be 300, if I'm not mistaken, which I don't think I am. So the bottom rectangle is going to be 300 millimeters squared. But then we get to a tricky part. This face right here. Well, we're missing this side length right here. Because this rectangle right here has a side length of 20 millimeters. But then this one here, we don't have anything. And this is where our Pythagorean theorem comes back to greet us. In order to find this side length, we have to do the Pythagorean theorem to find out the length of the hypotenuse. Oh joy, it comes back, but we know how to do it. So let's have at her and see if we can figure out what the side length is. So we have the triangle of, maybe that's okay to do right there, I suppose. I don't want to get it cut off by the camera, but I think I have space. So I have this triangle, and I have 15 right here, and I have 8 right here. So how do I find the hypotenuse? Well, it's this side length squared plus this side length squared, because these are the two legs of the right triangle. So if I think about a squared plus b squared, for this being c, a squared plus b squared is c squared, so 8 squared plus 15 squared is c squared. That's 64 plus 225 is equal to c squared. 64 plus 225, I'll do the quick math for you, is 289. And that gives us with 17 is equal to c when I square root both sides. So that means this side length here is 17, which means this side length here is 17 millimeters, which means this side length here is 17 millimeters. So when I multiply this by this to get the area of this last face, 17 times 20, I think that's going to be 340 millimeters squared. So I add that to my running total, and that total works out to be 340 and 160, I see, will give me 500. 300, so I will go 500 millimeters squared. That'll get rid of these two. 2 times 60 is going to be 120, and 120 plus 300 will be, oh boy. If only I had an editor, I would be able to put a certain Snoop Dogg song over top of this video right now. But alas, I do not. So, missed opportunity. But we have 420 millimeters squared. When I put those together, I get 920 millimeters squared, and that will be the surface area of that triangular prism. So, that's triangular prisms for you. What we're going to look at afterwards, coming up, is cylinders. And when I have a cylinder, I can get you thinking about it. We have to find the area of the top and the bottom circle. So we have to think about how to find the area of a circle. But how do I find the area of that tube part? Well, let's say this length was 10, and I took this piece of paper, and I had to make that cylinder. Well, if I wrapped it around like this, and I have this cylinder, where's that length of 10? That length of 10 is right here. So when I unwrap it, oh, I actually get a rectangle with 10 right there. But what is this length? Well, let me wrap it up again. Oh. Maybe something to do with what this length is. Can't hold very well, but what this length is. Maybe think about that.